Hello, everyone, and welcome to the 8:30 a.m. to 9 a.m. session of the 2024 OpenSimulator Community Conference. In this session, we are pleased to introduce the presentation WebRTC Voice for OpenSimulator. Our speaker is Misterblue Wave Robert Adams. Robert Adams has been an OpenSimulator core developer for many years. His OpenSimulator work includes BulletSim Physics Engine, the DSG Distributed Scene Graph, Simulator Experiment, and many performance improvements. Other OpenSimulator projects include the Dockerizing of OpenSimulator, the experimental Bazel web browser viewer, and the code addition to several of the independent viewer projects. His current interests are in distributed computing and robotics. Please check out the website found at conference.opensimulator.org for speaker bios, details of the sessions, and the full schedule of events. This session is being live streamed and recorded, so if you have questions or comments during the session, you may send tweets to @OpenSimCC with the hashtag #OSCC24. Welcome, everyone. Let's begin the session.
Hello all, I'm Robert Adams, mostly known in world as Mr. Blue Waves, and I've been working on adding WebRTC voice to OpenSim. So this presentation is going to be kind of pointed towards developers and grid operators. As a user, you shouldn't see any difference with voice. That is, the little ball will show up over your head and you can talk. But this presentation is going to give details on how SecondLife is implementing the WebRTC voice, and also then describing my solution. So in the beginning, SecondLife used Vivox. Vivox is a game service that people could play games together and talk to each other, and SecondLife used that. And OpenSimulator has been relying on the fact that it's been free for our use for all the years. And Vivox, being an old service and been updated and that sort of thing, is being retired. So SecondLife, Linden Lab, decided they had to change. So they're bringing up their own servers for spatial and non-spatial voice. And they're building a solution that's roughly based on the WebRTC protocols. And the third-party viewer people have this problem of what they're going to support, and some of them are saying they're just going to go all SecondLife and not support Vivox at all, and that would mean that OpenSimulator didn't have a voice solution. So first, what is WebRTC? So I'm going to tell you everything about WebRTC in 3 minutes. So WebRTC is a set of standards that was originally designed for creating audio, video, and data real-time streams between browsers. That is, it was meant for browsers. And there's probably 10 plus standards that it's based on. But the base ones that you might hear around there's RTP, which is a real-time protocol, which is a protocol for moving streams of data. Like TCP is made for reliable transmission of blocks of data. RTP worries about latency and bit rates and keeping a real-time stream running. The session description protocol is the way the two browsers negotiate the connection. It's about what codecs they have and what bit rates they can do. SIP and ICE, they're the protocol and the servers for negotiating a connection between browsers that are scattered around on the internet. And then you'll hear of stun and turn servers. Those are proxy servers that for keeping the stream around. So let's say you have two browsers sitting out on the internet. The browsers usually talk to a directory service. They don't have to. You could just keep passing URL to each other. But usually, when you start your Zoom session, you go somewhere and you say, I want to join this session. And it gives you the initial connection. Then you talk you negotiate the connection. What is the connectivity between the two browsers, given the fact that people are probably behind firewalls and that sort of stuff? And then eventually you start a RTP stream between the two browsers. And usually, mostly on the internet, since there are a lot of firewalls out there, you're going through some sort of proxy servers out there, and that's what the stun and turn servers are. So that provides you the connection on the internet to go. But when you negotiate the connection, like if the two browsers are inside the same company, inside the same subnet, they can connect directly to each other and not use all that cloud stuff. And that's sometimes you'll hear that WebRTC is decentralized. That is, it doesn't need the cloud services, and you can directly connect both the source and the destination without using any cloud services, which is so WebRTC doesn't require the cloud services, but really most everyone uses them. So like if you have a meeting of 5 people, say there's 5 browsers, you'll negotiate and set up this star organization where the data is moving in between each of the browsers. But you notice that each of the browsers has 4 connections because it has to talk to the other 4. And that puts a load on the browser because it has to have all the connectivity, the bandwidth, and it has to have the computation to mix all the audio streams. So there's also the possible having an audio mixer where the browser just talks to a mixer who mixes all the audio and get the streams together. This is also possible in WebRTC things, and it has multiple advantages. One advantage is that the browsers do not have to do all the computation, do not have to do the mixing of the sound. And this takes the load off the browsers. And also the browsers can't see the other people. That is, it only gets the stream, so it doesn't get the IP addresses of the stream. So this is the solution that Linden Lab went for. So they're building an audio mixer, and it takes the load off the viewers, which is Linden Lab is very concerned about the computational load that the viewers create on your computer, and so that takes the load off, and also it hides the IP address of the other people for privacy. So this is what you get. You get viewers talking to the region simulator. They talk to the region simulator, do the basic WebRTC handshake. So they exchange the SDP offer and answer, it's called. And then the viewers make an RTP connection to, in my solution's case, a Janus server. So I'm using Janus Gateway, which is an open source WebRTC server that's out there. It has an audio bridge feature or plugin which creates conference rooms. So the conference rooms are rooms that people talk to each other in. And so multiple people could join these rooms and hear everyone else. There's some position features available in it. So it has the start of the spatial stuff that we need for OpenSimulator. And so it was a good starting point. So Linden Lab decided not to provide their servers for our use. That is, like Vivox was available for OpenSimulator for free, but Linden Lab is not doing that for us. But they were very generous in publishing all the protocols. That is, we know the features and roadmaps, and also they publish the detailed protocol specification. So we know exactly what data is going back and forth. And so a solution was possible to be built. So this is kind of a picture of how you can set up the service using my solution. That is, the region simulator talks to the grid server, and a Janus server is run alongside the grid service. So the grid provides an audio mixer, and the viewer talks to the region and eventually connects to the Janus server. I also have the solution where a region can run its own Janus server, so it could have its own local audio mixer, which provides a load solution. That is, if you want to keep stuff local for either security or for the load that you're using, and not rely on the grid service. So these are two configurations that are possible. And so, like I mentioned earlier, you're using the basic WebRTC protocols, but it's not a full WebRTC solution. So they do what's called the SDP offer answer handshake, which is the basic setup of a WebRTC call. And then they create a proper RTP connection to the mixer service, but it's not a generalized implementation. So you're not going to be able to connect to your Zoom meeting or anything like that. So it's a very basic use of WebRTC, and it allows us to build a easy solution. And we can add, since ours is all open source, the OpenSimulator is open source and the viewers are open source, we can add our own interesting extensions if we want to do interesting mixes and that sort of stuff. So let me quickly, I'm going to go through the handshake that happens. It'll expose to tell people what's really going on. So normally what happens when the viewer logs into the grid login service, it gets a pointer to the region it's supposed to talk to. And then it connects to the region, and of the things that the region gives back is a feature list of what services the region supports. And the new feature is voice service, which returns WebRTC now. It used to return Vivox. It now returns WebRTC. And this is independent of each of the regions. That is, theoretically, regions can implement different voice services if they wanted to, but now what happens is it returns WebRTC. Then the viewer talks to a capability, which are the connection services on a region, and says, hey, I want to make this connection offer. The region talks to the Janus server to set up and gets the SDP answer. It sends the answer back to the viewer. Now the answer includes all the stuff like the network address of the Janus server and all the other connection information that's necessary, as well as the codec being used and the bit rate. And so, oh, I missed a slide here. And so then the viewer then makes a connection to the Janus server for the real-time protocols, the RTP stream. One feature of the stream that Linden Lab is generating is not only does it have audio in it, but it has data. And the data includes all the position information. So it sends little JSON formatted blocks that have the sender position and listener's position, mute information, and also volume information. The my initial implementation doesn't interpret this stuff, so while they'll have voice, it won't be spatial yet. That's a piece of future work, but I'll get there in a second. So the project I created is called OS WebRTC Janus, and it's in my Misterblue GitHub repository. It's an add-on module for OpenSimulator, so that you just check it out into the add-on module directory, build the OpenSimulator sources, and voila, you have WebRTC. It has a region module that connects into the region, that provides the capabilities and also makes sure that the region says that he supports voice service WebRTC. It has a voice service module, which is the thing that takes the capability requests and routes them to the right place. That, as I said, you could go to the grid service or to a local Janus service. Then there's the WebRTC Janus voice module that actually provides the connection to Janus. In theory, someone can make other solutions. If someone has their own audio mixer and wants to do it, they replace this part of the module. And then there's a voice connector, which does the connection from the region to the grid. And those are the main components of WebRTC voice. And voice setup is pretty straightforward. You just enable the voice, say which things uh, get pointed to and loaded. That is, if they're both Janus, if it's a local Janus service, you specify that. If it's a grid service, specify that. And then you have to specify the parameters for connecting to the Janus service. At the moment, I'm using a simple API access key, which needs to be specified in the init file, and the admin stuff to control the Janus server. I also built WebRTC Janus Docker, which is also another GitHub project. And what this does is it builds and packages a Docker container with a Janus server that's set up to work with OpenSimulator. You just edit two files, one that gives ports and things like that, and another one that has the secrets, which are the access tokens. And so you can just run that Docker container, and it creates a Janus server that you can run. So the state of the Janus project. It compiles into the OpenSimulator sources. It has the README file on the GitHub repository. It provides non-spatial voice so far. So I have not done the modifications to Janus to do the listen to the data channel and do the spatial stuff, but that's simple matter of programming. And the group voice, at the moment, the connector to the grid service is not working yet. And group is it's non-spatial and also restricted to per region. So what needs to be done is spatial voice, possibly modify the Janus audio bridge plugin, which seems to be the easiest way to go. Add the voice controls. There should be, SecondLife voice controls include muting people and volume for individuals, and that needs to be added. The grid connector, like I said, and then hardening. Hardening is about how you recover from errors, because viewers will crash, the Janus server might crash, the internet gets connectivity problems. How do you recover from that? And to run it as a real grid service, it needs a bunch of hardening. And so what's next? So any developers can join the implementation. That GitHub project for the thing has a project page on it. Try it out, give issues, and join in. I haven't really talked a lot to the third-party developers. I've been testing with Firestorm, which seems to work great. You can talk to me on the OpenSimulator Discord. There's an invite on the screen, which should work. I'm Misterblue guy over there, and you can email me. So I'm just a lone volunteer developer. More features will take time, and the integration into core and that sort of stuff will take time. But we have voice starting up on for OpenSimulator, and it's starting to work. There is another grid, Canadian grid, that is using it now, testing it out. In OS Grid, there's a region called Blue Land, just BLUELAND, which is running the WebRTC services. I have my own Janus server up, and you can go there and give it a try. And there you go. Thank you very much, and I hope to see lots of issues showing up on my GitHub project.
Hey, thank you, Robert. We had a few questions for you during the session, and I may have missed a few because I was trying to type and enjoy this amazing session. Lisa asked early in the talk, what prevents a hack of the proxy Janus turn, etc., to eavesdrop or record convos for malicious purpose? Does it have true end-to-end encryption?
The implementation that I'm running now does not have end-to-end encryption. That is, I have not gone up to um, the adding the end-to-end secure connections for the audio stream yet, but that's uh, to be done. At the moment, the connection is just from the viewer to the Janus server and from the Janus server to the other viewer, and so the it doesn't use a Turin server at all. It just uses the Janus server as an audio bridge. It acts as a Turin server. So there isn't an extra component to be taken over.
And she also asked max voice connected users per parcel with low latency and high quality. Is it in stereo or mono?
The Janus implementation is in stereo. And so that's what makes um, the spatial stuff eventually easy to add. In fact, Janus has all the stuff to do it outside using its own protocols. But what needs to be integrated is the Second Life data stream information and do the stereo stuff for that. Um, the implementation does the protocol for the voice does include parcel voice and as well as group and person-to-person voice. So all of those should be possible, and it's all in stereo.
Thank you. Let's see. We had another question from Nick Zwart. Does it run on older versions? And I'm assuming it means for older versions of the viewer, or
Yeah, it needs with the newer viewers that support WebRTC, and I don't know the fire. I know Firestorm in particular has they had their beta program out, which had the WebRTC support, and I noticed the latest release of Firestorm, the released viewer, does WebRTC. The Firestorm people have done so far a reasonably nice job in that they can run either Vivox or WebRTC. So if the region actually says that it supports WebRTC, Firefox uses it. And like I said earlier, I haven't talked to all the third-party viewer developers, and I need to start testing with them. But it should, since I'm just using the published protocols from Linden Lab, it should work for the ones who support WebRTC.
thank you. And by the way, we had a message from Eris noting that the Discord invite that you pasted has expired, so they may need a new one. I did give them your ID name in the chat as well. So
Okay, well,
yeah,
and okay, I did try to select the does not
sure, sure.
expire thing on that, but they've
It's
disappeared.
not easy.
Yeah.
So we had another question from Frank Ruloff. Can we still use another audio server if this was added to OS? And I think you just answered that with the Firestorm latest viewer and having the option for two. But Frank's asking, can we use another audio server? And I'm not sure if he means Vivox or maybe something new entirely.
Yeah, the like I said, let's see back here on this slide, the the region module and the service module are generalized modules that take the capability connections and pass them through to the actual voice service. I've implemented the Janus voice service. Anybody else can implement any other one. I know there's I had originally looked at building a voice mixer using the audio service that's being used in the Overte project that actually came out of Hi-Fi a long time ago. Um, And so, yes, you can build other services, and then you just point at them in the configuration file, and that's what they get used.
Great, thank you. Any other questions or thoughts, comments before we close the session? Let's see. Rain, Lisa has a comment for Rain. There is a custom version of Firestorm we're testing. Yes, there are beta versions. And if you join the beta version, they do have that link online. They like you to join the group in Second Life so you can give feedback, even on the OpenSimulator version, on its use. Well, thank you, Robert, for such a wonderful session. And please, as a reminder to our audience, you will want to check out the conference.opensimulator.org to see what is coming up on the conference schedule. You won't want to miss our next session, which will begin at 9:30 a.m. in this keynote region, and it's entitled The Panorama, Simulating the Journey by Train from Manchester to Liverpool in 1834. Also, we encourage you to visit the OSCC24 Poster Expo in the OSCC Expo 3 region to find accompanying information on presentations and to explore the hypergrid resources in OSCC Expo 2 region, along with our sponsor and crowdfunder booths located throughout the OSCC Expo regions. Thank you again to our speakers and to the audience.